So many SSDs. So little time.
SSDs can be broken down by two major categories, by form factor and by interface. The former dictates compatibility, while the latter dictates the level of performance. Were you expecting an intro? Yeah, we don't do those here. You clicked on the video, so you know what it's about. Let's start with form factors, of which there are three. First, the 2.5 inch, the bread and butter of SSDs for the longest time, and by far the most common form factor. It is distinguished by its standard rectangular shape and, much like hard drives, requires both a SATA power and a SATA data connection for it to work with your system. The main advantage of this form factor is its broad compatibility, as it can be installed into pretty much any semi-modern motherboard without hiccups. The fact that it is considerably smaller than standard 3.5 inch hard drives also means that it occupies less space. Another advantage is their affordability, as they are readily available and enjoy great economies of scale, which is why their cost per gigabyte is significantly more attractive than certain other types we'll get to in a moment. Next up is M.2, a much smaller and much more recent form factor that measures 22mm in height and up to 110mm in width. Other than size, what distinguishes M.2 drives from their 2.5 inch counterparts is that they don't need any extra cables to work, as they can be installed directly into any motherboard with at least one M.2 slot. This advantage also proves to be a shortcoming, as this convenience and, spoiler alert, advantage comes at the cost of compatibility, as they can only be installed in systems with M.2 sockets, limiting them to motherboards made in the past 5 years or so. But it's also worth noting that this is seldom an issue nowadays, as even current budget boards ship with at least one slot. Last, and quite possibly least, is PCI Express expansion cards, which plug directly into a PCI Express slot on your motherboard. Much like M.2, they require no extra cables and boast a significant as we'll see in a second, but do come with the caveat of occupying a PCIe slot. Okay, now on to the second category, interface. First, we have SATA 3, which is used by all 2.5 inch SSDs, except U.2, but nobody uses those, so don't worry too much about them, as well as some M.2 drives, labeled M.2 SATA. The SATA 3 interface's max transfer rate is capped at 6 gigabits per second, or 768 megabytes per second. Most SSDs don't quite saturate the interface and tend to top at around the 550 megabyte per second mark in sequential reads and writes. This speed, while 4 to 5 times faster than a typical mechanical drives, is still no match for our next interface, PCI Express, which is used by some M.2 drives labeled M.2 NVMe or Non-Volatile Memory Express, as well as by the PCIe expansion cards we just covered. PCIe, as alluded to earlier, boasts much higher bandwidth than SATA 3. The actual speeds depends upon how many PCIe lanes the drive in question uses to communicate with the system, which is typically either 2 or 4 lanes, with a transfer speed of up to 18 and 36 gigabits per second respectively, PCI Express 3.0. PCI Express 4.0 is also a thing and offers double the 3.0 bandwidth, but the short of it is, they're not worth it just yet. As you've probably guessed, these speeds are several times those of SATA 3, but do come at the cost of, well, extra cost. M.2 NVMe drives in particular are considerably more expensive than even M.2 SATA drives of the same capacity, and also run a lot hotter under heavy load. It is also worth noting that M.2 SATA drives offer no performance benefit over 2.5 inch drives, and are often priced identically to their rectangular brethren, so be mindful of that if speed is what you're looking for, and make sure to snag an M.2 NVMe, which, other than branding, can be distinguished by the different physical connector it uses. It's also prudent to check if both your motherboard and CPU support NVMe SSDs before you make any purchase, as there'd be no point in installing a 4-lane NVMe into a slot that, for example, only supports 2 lanes. A quick shout out near the end goes to the barely noteworthy M-SATA, which is more or less the same as M.2 SATA, and quote from the top result on Google, an M-SATA SSD has a smaller form factor than a standard SSD and is designed for use with portable, power-constrained devices such as laptops, tablets, and netbooks. So, in summary, these are slower and cheaper, while these are faster and expensive. Thank you very much for watching, and I hope you learned something.
He's strong, but he's not as fast as us. What's the plan? Well,
Pardon me. I dozed off whilst you were talking about how fast you are. I also killed you.
I didn't see that coming.